Good evening, we enthusiasts, and today we are going to launch ourselves and we are going to see why, when a rocket is launched after some time, why is it that some parts of the rocket just fall off, they detach themselves from the main body of the rocket. And it's always fascinating to see the rockets getting launched. And in case you missed what I showed, I'll just show it to you again. It's very, very interesting, the amount of energy used. So many principles of physics are used in the launches of rocket, and it's so fascinating to see a rocket fly in the sky, land back, the space shuttle. It's so interesting. Almost everything that you learn in physics is used over here, and no wonder that's why it's called as rocket science. So we're going to see what is the reason behind this. And also, I have some amazing questions at the end of the session on Angry Birds. I hope you have played the game called Angry Birds or at least heard about it. And if not, don't worry, you will see it by the end of today's session. So welcome aboard. This is Shreyas here, your master teacher for physics at Vedantu going live. And welcome all the V enthusiasts. My name is Shreyas and I teach physics at V Enthuse and all the regular batches in Vedantu. And I have been training kids for JEE, for qualifying, for getting a good rank in the JEE examination, in the JEE advanced examination, and some of the Olympiads in KVPY for a very long time. And many of my students are in the top-notch institutes, the topmost institutes in India. And I hope that one day you will be there and you will make me, your parents, your friends, your relatives also proud. And that's why we have started this channel, V Enthuse. And in case you have not liked or subscribed our channel yet, please do that right now. Unless you like and subscribe our channel, the way YouTube works is that it won't recommend you our channel, it won't recommend you our videos, so you might miss out on all the important notifications, the videos, all the tips and tricks that are required to crack the examination. So welcome aboard, and let me just say hello to everyone. Hello Techno, Ryan, Fida, Janvi, Rajat, and Murli, Kirito. Welcome Jumna, welcome Achut, welcome Ashutosh, welcome aboard, welcome. Glad to see all of you. Welcome VSG, Science Priya. Very good. Hello Shreya, hello Aarti, hello Ravindra, hello NIT Jalandhar, kya baat hai? Hello Palak. Hello everyone. So we are a nice small family. Hello Giri, okay. A lot of new students also out here. So guys, remember one thing, unless you type, I wouldn't know that you are here. So make the chat box active, say hello, say hi to everyone, interact with everyone, also greet everyone, say thank you when somebody helps you. Also, if a new member joins in, help them. So you have to form that bond in this family at V Enthuse. That's what we are here for. Very good. Welcome Sneha. Thank you very much. Well, let's begin with our class then, without waiting for more time. And in my last session, we have talked about what is momentum, what is impulse. We have seen how force can change the momentum, and that change in the momentum was called as impulse. And we have seen the formulas related to the change in momentum. We have calculated the average force. We have talked about so many different things about the changes in the momentum. Now in today's session, we are going to talk about what happens if momentum is constant and when is it constant. So these are the things we are going to discuss, and believe me, there is a separate lecture. Yes, there is a separate lecture next week just on types of collision. Like I have promised you, I am not going to burden you with too much information in one lecture, because at V Enthuse we promised that we are going to tell you everything properly. We're going to make you solve problems. But yes, keeping in mind that the exams are just 2 or 3 months in, from now. So do not worry, all the 11th, 12th and the dropper students, you are at the right place, because if you hurry, then that's it, you will not learn anything. So we are going to keep the pace just right, so that we are going to complete everything in the next 2 months or 3 months. All right, do not worry. All right, welcome Ankit, welcome Suhas. All right, so how can momentum be constant? Look at this example. Using a stick, you hit the striker, the white ball goes and hits the red ball, and you can see the momentum is first transferred from the stick to the white ball, and then from the white ball to the red ball. So it is getting transferred from one object to the other, but the total momentum is constant. Yes, this red ball has stopped. Now you can guess why the red ball has stopped. Can you guess why the red ball has stopped, guys? Why did the red ball stop in the first place? Why didn't its momentum remain constant? Is there a reason? Is there a reason? Yes, very good. Friction. So now you would have got some idea about why and when momentum remains constant and when it does not remain constant. So keep that in mind. I'll be telling it to you in words. Look at another example over here. This is not a simulation, this is an actual video. You can see the stick hits the white ball and that hits the black ball. It transfers the momentum, but the black ball gets a sudden impulse from the edge of the table, so the direction gets reversed, and the black ball again hits the white ball and it transfers the momentum back. So lot of collisions, lot of momentum transfers happening over here, and you can see how momentum is getting passed on from one object to the other. So now let's make the general principle, and that is called as the conservation of momentum principle. So understand, this conservation of momentum principle states that if you have a system, now that system can have one body, two bodies, or three bodies, doesn't matter. Alright, many bodies can be there in that system. Alright, if the net external force, alright, if the net external force acting on it is 0, then understand, it implies that the total momentum of that system is constant, or it is conserved. This is called as the conservation of momentum principle. Like you saw in the previous animation, that red ball stopped after some time. Why did it stop? Because on the red ball there was a frictional force. So net force was not 0. So that's why the momentum was not constant. So this principle is only obeyed under the circumstance when the net force is 0, else it will not be obeyed. So there could be forces, but as long as they cancel out each other, then it is fine. Understand that. I hope this is very, very clear. And just a recap of the previous session. In center of mass, I have told you the momentum of the system is nothing but momentum of object 1 plus momentum of object 2 plus momentum of object 3 and so on and so forth. And that is also the momentum of the center of mass. In case you have forgotten that, I am just recollecting those things which I have told you before, and in case you are new, I hope now you remember this, or now you will note down all these formulas, because this will be needed for solving problems as well. JEE Mains, Advanced, NEET, whatever it is, KVPY, everything. Alright. Okay. So black ball after hitting the white ball still moves. Well, understand, yes, that is possible, because not all collisions are elastic in nature. You will learn that in the next class. So it's not necessary when two balls hit, one ball stops and the other ball goes. That only happens in certain situations, and that is called as elastic collisions, and that too when the masses are same. So when all things do not match, you will see that when the black ball will hit the white ball will move, but with slightly less speed, and the black ball will continue moving with slightly smaller speed. So that is possible. I hope this is clear, Suhas and other people. Alright. Now, if this is clear, let's go ahead and let's start solving problems. Very good, very good. So let's start solving problems. Concentrate on this session, guys. Now, look at this simulation again. You can see in the first part, momentum of mass 1 which is coming is there, and in this example all the momentum got transferred to the second ball. So you can see the total momentum of the system is conserved. Now you might be like, sir, when this ball collided with this ball, don't they exert a force on each other? Yes. So if they exert a force on each other, how is momentum conserved? Well, here is the answer. That force is an internal force. So internal forces cannot change the momentum of the system. Understand that. So the moment you take both the balls as a system, understand the force of collision is an internal force, so it will not change the total momentum of the system. It can only change the momentum of individual bodies. It can reduce one's momentum, but it can also simultaneously increase two's momentum, and that's how it works. Now, if this is clear, let's go to the next problem or the next simulation out here. This is a very famous setup and it is called as the Newton's cradle. And what happens in this cradle is you have many swings, and you can see that when you raise one ball and you leave it, as soon as it comes down, the potential energy gets converted into kinetic energy, and that kinetic energy of that ball, if it is there, that means it also has some momentum, and that momentum gets transferred to the yellow ball, and within no time, because they are almost in contact, it gets transferred to the green ball, and then it almost gets transferred to the blue ball almost instantaneously, and then it almost gets transferred instantaneously to the dark blue ball. Now, this process would have continued if this process was very ideal, but when you do this in reality, so if you drop the red ball from this height, the blue ball won't go till the same height because some amount of energy is remained over here, some amount gets lost. So that's why this dark blue ball won't go till the same height in reality. But in ideal situations, yes, if there was no loss, there was no surrounding में heat loss, light, etc. created, then yes, the height from here and here will be the same. But we know that all the collisions generally around us involve some kind of energy losses like deformation, sound, heat, light, etc. So that's why it won't go up till the same height. Is this clear, everyone? Is this clear, everyone? Yes, eventually they would stop. Yes, very good. Eventually it would stop. Amazing, amazing. Very good, Janvi, Fidar, Ryan, Science, Priya, Krito, Achut, बहुत बढ़िया. Very good, Nijasan. Now, let's get going. This is your first question on your screen coming up. Let's see how many of you get this correct. So I will give you 1 minute right now. Can the momentum be conserved in a non-inertial frame? Remember, non-inertial frame, different frames of reference. So can you conserve momentum of a system in non-inertial frame if all the conditions are met? What do you think? Come on, I'm reading your answers. Yes, we are going to talk about inelastic collisions, etc. in some other lecture, and that is Monday's lecture or Tuesday's lecture. You will see we're going to talk about those kind of collisions. All right, let's see. All right, we still have some time left, and come on guys. Yes, Suhas, we have crossed more than 100 videos, and that is all because of your love and your support. Thank you guys. Very good, Ashutosh. Congratulations, happy birthday. Wish you all the best, Ashutosh. Oh, Sneha, you made a very bold statement out there. Okay. So the answer to this question is yes, it can be conserved. So what happens, guys? Imagine if you have a frame which is non-inertial in nature, and if you have a system, all right, and there are some forces on it, but let's say these are the forces acting on it, F1, F2, F3, etc. So F2, F1, Fn, etc. And we see that F1 plus F2 plus ... Fn, these are the forces, plus one extra force, do not forget that, pseudo force, Fp. Fp is that pseudo force, do not forget that. So plus the pseudo force, if this is equal to 0, only then I can say the momentum is conserved. Understand that? So total means exactly the total momentum will be conserved only if net force including the pseudo force is conserved, is 0. I hope you get this point. Alright, so remember that. Very good. Many people have got the answer, and I think somebody said, Sneha or Neha, somebody said that momentum does not depend on the frame. Let me try to correct you now. Momentum does depend on the frame of reference. Understand that, because velocity is a frame dependent entity. So when you change the frame of reference, let's say you move with the speed of a bullet, then for you the bullet will be at rest, and then the momentum of the bullet will be 0. So understand, momentum does depend on frame of reference, but the conservation of momentum principle is applicable in all frames of reference as long as net force is 0. This condition should be valid. I hope this is clear. Okay, I hope this is fine. Let's go ahead. Let's go to the next question. Is mechanical energy also conserved if momentum is conserved? That's your next question. Let's see how many of you get this. The countdown is starting right away. Is mechanical energy conserved when momentum is conserved? Always, never, sometimes. What do you guys say? Options A, B, C. Come on guys. Oops. अरे यार ये क्या हो गया? अरे so sorry guys. I think my hand just touched. So it just went to the next slide. I'm so sorry, but it's okay. I think most of you got that part, and that is sometimes. It's not every time. It's not every time that the energy is conserved. I just told you, remember that Newton's cradle? The momentum from this ball gets transferred to the next ball and then the next ball. So, energy is not conserved. Some energy is lost in the form of heat, light, sound, etc. Even that example of pool that you saw, just go back over here. See this example? Even in this example, not all the energy goes to the next ball, because understand, no collision is perfectly ideal as such in day-to-day life. So some amount of energy is always lost. So this question which says, is mechanical energy also conserved if momentum is conserved? Well, the answer is no, not always. Sometimes it is, sometimes it is not. Now I'll be like, when do you think the mechanical energy is conserved? Well, if the collision is really good, then only the energy is also conserved. And what are those good collisions called? Well, I'll be discussing those in detail in Monday's or Tuesday's class next week. Remember, Monday, Tuesday, Wednesday is generally reserved for 11th portions, and Thursday, Friday, Saturday is generally reserved now for the 12th standard portion. So today is Wednesday, so it's going to roll over to the next week, and we are going to continue with this chapter next week as well. So remember that. And yes, a lot of you know that is called as elastic collision. Bilkul sahi. So sometimes is the answer. And even look at this example. Imagine, wow, such a cool animation this is. Imagine a gun firing a nice big bullet. Alright, firing a big bullet like the one shown over here in this schematic. So you can see the momentum of the system before firing was 0. It was at rest. Now, after it fires, the total momentum to remain conserved, what will happen? If the ball's momentum is here, the cannon or the gun's momentum will be on the other side. So momentum here and momentum there, it's a vector quantity, right? So what will happen? It will get cancelled out. So the total momentum will still remain 0 because momentum is a vector quantity, do not forget it. Alright, yes, it's also following Newton's third law, and it can be explained by Newton's third law as well, but I wanted to see from the momentum conservation perspective. So yes, Sneha, momentum conservation does not depend on frame of reference as long as net force is 0, net force. There is a condition, if. Now, if this is clear, very good, very good. Is this clear, everyone? Now, think about it. In this problem, isn't the ball and the cannon both getting kinetic energy? Think about it. The ball also got kinetic energy and the cannon also got kinetic energy. Do you think these kinetic energies will cancel and the total kinetic energy will be 0? What do you think? Will the kinetic energy of the ball or the bullet and the cannon cancel out each other? Kinetic energy, will it cancel out each other? Yes or no? What do you think, guys? If you answered yes, then you guys are wrong. You guys are wrong. Kinetic energy is a scalar quantity. It cannot cancel. It's not a vector. Direction is not important. In fact, kinetic energy here and here or here and here will just add. Direction is irrelevant for kinetic energy. I hope you remember it, and I guess you forgot it. Yes, I hope you guys understood it now. So hence, understand the system has gained kinetic energy. Now I'll be like, oh my god, before firing, it did not have kinetic energy. Now suddenly, it has got kinetic energy. Where did the kinetic energy come from? Think about it. Where did this kinetic energy come from? Hello Hoin, welcome, join in. Hardik, just refresh and check your internet connection. Yes, it had some kind of spring or chemical energy stored in it. Yes, that explosion gave it that kinetic energy. So that clearly explains. Achyut, I will tell about Mahamenti by the end. Just concentrate right now. Let's focus on the topic. So do not deviate, Achyut. You know? Yes. So understand, mechanical energy may not be always conserved if momentum is conserved. This is a very good example. Yes. If the gun is tied hard, will the ball speed be more? I doubt it, Suhas, but what happens is the speed with which the bullet comes out depends on the gun speed before the explosion happened. Now, before the explosion happened, the gun was anyways at rest, so it won't matter. All right? All right. So, let's get going. Let's get going. And before we start more problems, I have some amazing 2D problems and amazing 1D problems which most likely you are going to make mistakes in. So that's why I kept it after this. So the pro subscription, guys, a lot of you who are interested in pro subscription, where you get online teaching with recorded classes, the notes and the test series, along with lots of assignments after every session. So after every session you get an assignment of questions, and after every chapter also you get a question bank, and also you get something called as the Tattva module, which has different level wise questions, and after every chapter also you get a test, which is a test conducted between all the students throughout our India, and you get a national level kind of ranking out there. And it's for 11th, it's for 12th, it's for droppers, for everyone, and no matter when you join, there is always a batch for you so that you are not left out. What happens in other coaching institutes, if you join late, then generally you miss out on a lot of portions. But in Vedantu, you almost have some or the other batch which is starting at some point of time. And the pace of the courses are obviously different depending on when you join the course. So you will not miss out much on anything. And even if you miss a lecture, you can always watch the recording. That's the best part, because of some reason, maybe you're ill or you wanted to go somewhere, etc. And you have the choices of English and Hindi batches, and also you get the choice of different micro courses like let's say you want to prepare for KVPY, or let's say you want to prepare for Olympiads, or any specific course in general by thousands of master teachers out there. So you will see a lot of micro courses out there which you can choose from, and all of them are free. Understand, all these things are free once you are inside the subscription. There are no costs after this. It's just like Netflix or Amazon Prime. I'm pretty sure you're well aware of that. All right. And what are the prices? Well, here it is for the dropper students. 20% off offer is going on. I'll give the coupon code shortly. Actual price for 6 months was 51,000. After discounts, it's 40,800. Per day price is 227, which is quite reasonable. And for the 12th standard students, the 6-month price is 39,000. But after 20% off, it comes out to 31,200, and per day price is 173 rupees. So that's again quite affordable. And for 2022 students, I don't think there is a slide there, but yes, it's also quite reasonable. I remember it's close to some 100 rupees per day or something like that if you take 6-month subscription. Okay, and you can just check the link below, all the details that you need for joining the course, what is available, what is there, how is it. You can get all the live experiences out there. Just click on the link, all the facts are there, and you can use this coupon code. Only this coupon code will fetch you the discount of 20% off. And what is the coupon code? SHHPRO. That's your coupon code, which is going to give you an amazing discount of 20%, and that's a huge discount. You will not get this discount anywhere else. All right? Yes. So actually KVPY is slightly less than JEE Advanced, and it's slightly more than JEE Mains. Shall we do some problems? What say, guys? Sneha, probably refresh your screen. Achyut, maybe you can message me personally and I can talk to you. Alright? Are you guys ready? Yes, the notes are handwritten. So whatever is written on the slide is also there in the notes which you get in the pro courses, apart from whatever is there already printed in the slide. So you get both the notes, the printed ones and the handwritten ones in the pro courses. Very good. So let's begin, and there we go. A 500 kg boat has an initial speed of 20 meters per second as it passes under a bridge. At some instant, a 50 kg Pandu, I don't know, maybe he wants to jump out of joy, I don't know, and he jumps straight down into the boat from the bridge. The speed, if the boat, after the man and the boat attain a common speed is how much? So this boat was moving nicely at a speed of 20 meters per second. This Pandu of 50 kg jumps onto it, straight onto it. What will be the speed of the boat and the Pandu together after some time? What do you guys think? Chalo, I'm starting a countdown. Let's see how many of you get it. Let's see how many of you get it. No, Pandu won't die to us, don't worry. Yes, Simran, Pandu is back. And Fida loves the hotness of Pandu. No, Achut, he's not committing suicide. Pandu is so happy. Looks like Hardik found a good smiley, very good one. Yes, Ankit, this is for 11th and 12th. For 11th, this will be a quick revision before your final examinations, and for 12th, this is like a revision for their 11th portions. Yes, it's for both. I've kept in mind both the standards. Yes, correct, Palak. I agree with you. What is the correct answer, guys? Come on, come on, come on. Is it A? Okay, let's have a look. Let's have a look what the correct answer should be. So the correct answer is A, and let's see why is the correct answer A. So let's go back 1 second, and what you need to do. Here is the thing. My system is Pandu plus the boat. Okay, so this is my system, and I will neglect the force by water. So that means the net force will be 0 on that system, obviously, and that tells me that the total momentum of the system is conserved. Alright, so this is a very important line. This should go on in your head. Maybe you have not written it down in words, but this is something which should go on in your head. Now let's apply momentum conservation. Initially, the momentum was only of the boat, and how much was it? It was 500 into 20. Pandu's momentum is 0. So like, sir, why is Pandu's momentum 0? Pandu is falling down, so he has momentum. Yes, you guys are right. But think, in which direction are we conserving momentum? I feel I'll conserve the momentum in x direction. Alright, so I'm conserving the momentum in x direction. So that means I should only worry about the momentums in the x direction. So Pandu's vertical velocity is irrelevant for me. So everything in x direction. Alright, so this is an x axis. What is the final momentum? Well, the total mass will be 500 plus 50 into the common velocity. So that is Vc. So just do that math, and Vc is going to be 500 multiplied by 20 divided by 550. I hope this is clear how we did this. I hope this is clear. Yes, Anke, don't worry, don't worry. We'll come up with something, don't worry. Yeah, it is 20 meters per second. Is it clear? That's how you get the answer. Amazing, guys. This was introductory warm-up question. I hope you guys have all got little bit warmed up. You guys are getting that. You guys are getting thawed. If you are frozen, I hope you guys are getting thawed, because I've just put you in that microwave and I can hear some gears cracking and the squeaky noises in your head, because slowly your nuts and bolts and gears are slowly started to move. Yes, your brains have started to work. Very good, very good. So keep it up. Very good. Let's go to the next question, and this is going to be a very amazing question. Just look at this. It's so amazing to just see a rocket or a space shuttle just fly up in the air, isn't it? It's so amazing. So let's have a look, and let's see why does a rocket relieve a part of it and detaches itself from the rest of it, and you will see a beautiful thing happening out here. So a space shuttle, while traveling at a speed of 4,000 kilometers per hour, my god, tremendous speed, with respect to the earth, okay, ejects a module. You can see that it ejects a module backward which weighs 1/5 of the residual part. 1/5 of the residual part. That's very important. If the shuttle ejects the disconnected module at a speed of 100 kilometers per hour, with respect to the state of the shuttle before the ejection, find the velocity of the shuttle. So there's a lot of play of words here. So concentrate and we'll solve this question together. Alright. So I'm going to ask you some questions. You need to keep on answering in the chat box. This question is not as easy as you might think it to be. So let's get going. And there we go. So initial. Now this is the trick. Guys, remember, this is the trick for the chapter. What is the trick which Shreyas Sir is telling you? I am telling you that whenever you want to solve energy problems or momentum problems, always draw in your rough work before and after situation. If you draw momentum conservation or energy conservation problems in the same diagram, there is a good chance you will make a mistake. When do you draw only one diagram? For Newton's laws. Alright, whenever there is a before and after kind of a situation, always end up drawing two diagrams and draw the relevant information in each diagrams. Only then you will not commit silly mistakes. Is that clear? Okay. So now let's do this. Hold on, Ankit. Maybe you're right, maybe you're wrong. You never know. You will see that. So this is the before diagram, and what do we know about it? Well, it is moving with a speed of 4,000 kilometers per hour. And the module which is being thrown out is 1/5 of the residual part. 1/5 of the residual part means what? If this part has a mass m, then this part has a mass m by 5. And the total weight will be m plus m by 5, which is nothing but 6m by 5. This is very important. A lot of people do mistakes. I hope, Ankit, you did the same thing, else your answer is wrong. Alright, is this clear? No problem, Vesh. Join in. Okay, residual means the remaining. Residue, what is remaining? So this is what is ejected, this is the residual. I hope this is clear. 17S heard me? Alright. Now, if this is fine, yes, very good, Nisar. And now, if this is clear, read the next part. The module is ejected at a speed of 100 with respect to the state of the shuttle before the ejection. What was the state of the shuttle before the ejection? 4,000. Now with respect to 4,000, the module is thrown with relative to it downwards with what speed? 100. So think about it. What will be the speed of the module? Guys, come on, type it in the chat box. What will be the speed of this remaining part? This part, small part. And which direction will it be? Up or down? Hold on, Devendra. 1 second. I know, Suhas. I couldn't find a better diagram. What can I do? Yes, you can think of it like a bullet. 100, down, up. Well, it will be, guys, read the question carefully. Speed is 100 with respect to the state of the shuttle before. With respect to the shuttle, not with respect to the ground. So with respect to the ground, what will be the true speed? Think about it. My shuttle is going 4,000 kilometers up. With respect to me, it is going 100 down. Think about it. My shuttle is going 4,000 up. With respect to me, 100 down. Effectively, it is going up only, right? How much is it going up? 3,900. So this is actually going up with a speed of 3,900. I hope this is clear now. Yes. And it is not going down, Techno. You guys are wrong. It's going up. Understand? It's being thrown down with a speed of 100, which is much less than the speed of the rocket itself. Alright? Yes, Yandala. I will be doing electricity tomorrow. Alright. So now the question is, what is this speed? That is why this question is very tricky. A lot of people make mistakes and they get wrong answers. They think, oh, it's so simple, but it is not. A lot of concepts, relative velocity, mass is 1/5, what is the meaning of residual, all these concepts are involved. Now, conserving momentum, right? So conserve momentum just before and just after. So what is the momentum before? Think about it. It will be 6m by 5 multiplied by 4000 is equal to this one, m by 5, right, into 3900 plus m into v. That is what it will be. M will get cancelled from everywhere. So therefore, I'll get V is equal to, now take this guy on this side. So you will get 6 multiplied by 4000 minus 3900, this divided by 5 and this divided by 5. Now try and calculate and let me know what the answer is, guys. Okay, very good, Ankit, if you have answered it. Come on. Very good. What is the answer, guys? Come on. Come on, I'm leaving the screen for you guys to calculate. Come on, everyone. Is it 4722? Think about it. Think about it, guys. Check the calculations once more. I think Ankit is correct. Yeah, be careful, be careful. Check your calculations. 6 into 4000. Come on, guys. 24,000. 24,000 minus 3,900. How much is it? Yes, 20,100. And then divided by 5. Isn't it 4020? Isn't it? Very good, very good. I didn't understand what you said, Neha, but if you can be more specific. Very good. So the correct answer, guys, is 4020. Okay? So that's how it is. Did you see the speed of the rocket increased by some amount? How many kilometers per hour did it increase by? 20 kilometers per hour. Yes, it increased. So that's what happens when something is ejected. But this speed is very less, 100. If you throw it with much more speed, then the speed which the remaining part will get will be even more. Understand? And that's what happens in reality. Very good. So let's get going. I hope everyone is clear. Thank you, Ankit. Thank you, Ankit. Let's get going. Let's see how many of you get this question. I'm starting the timer in a bit. A shot, a bullet moving with some speed collides with a stationary block. Let's say that block is on a smooth surface and comes to rest inside of it. It sticks inside it. And the mass of the block is 14 times the mass of the shot. What is the energy which is lost? Very interesting question. Let's see how many of you get this. 1 minute. Okay, I'm reading all your chats, guys. Come on, come on. You can get going. Come on, start solving. Come on, everyone. 14 joules, I don't know, let's figure it out. Maybe, may not be. Somebody says 16, somebody says 14. Okay, let's have a look. So, one sec. Okay. Now, the bullet has a speed of 150. This is at rest. Eventually, both of them move together with one common velocity because the block and the bullet, they move together. Alright, the bullet comes to rest in it. That is what is mentioned. Now the next part. What about the masses? The mass of the block is 14 times more. So if this is m, this is 14m, and the total mass over here will be 15m. That's how it works. These are the masses. So conserve the momentum. What is the initial momentum? M into 150. The block is at rest. So understand, this is the bullet and this is the block. And this is obviously before the collision happened. What is going to happen after? Remember, I have always shown two diagrams. And what is going to happen after? Think about it. Is combined mass is 15m and the new velocity is unknown. So this situation is afterwards. So just rearrange and you will get the velocity as how much? 150 by 15, which is nothing but 10 meters per second. So that is what the new velocity is. But that's not the question. The question is, what is the energy lost? So how do I find the energy lost? So the energy which is lost will be initial energy minus the final energy. Now what is the initial energy? It will be half into m. What is m? M is unknown, into 150 square minus final energy, which will be half multiplied by 15m into the final velocity, which is, think about it, 10 square. So just rearrange it and you will get this as 150 square minus 10 square, correct? And you will have m by 2 over here. Now simplify this. M is not given, so your final answer will have m, and most of your answers did not have m. I don't see if m is given anywhere else. I don't think so, it's given. So your final answer has to contain m. Very good. How did I take it as 15m, Sneha? Because think about it. The bullet and the block, both mass will get added. Yes, Kirito has answered it. Yes. Very good. So as the wood's mass won't reduce, right? Why will it reduce? The bullet has got into it. There is nothing falling off the block and all that. Yes. And what else is there? Oh, there is 15 also in that. Oh, my bad. Yeah, 150 square and there is 15 into 10 square and there is m by 2. All right. Figure it out. How much is it? So as neglect that. Come on. You are studying for JEE. And let's say the wood chips. What will you do then? Is it given to you? What will you do? Okay, let's say the wood chips. What will you do after that? There is nothing you can do about it. All right. So you have to sit and calculate. Come on, guys. Figure out the answer. Come on. Yes, correct, Jumna. Very good. So I was waiting for it. Yes, it is 10,500 m. That is the answer. It's 10,500. Okay, this is 10,500 m joules. Very good, Janvi. Yes, for JEE you have to ignore. Yes, correct. This will be in joules, provided m is also in kgs. Excellent, guys. I hope you guys are understanding the level of problems over here. And did you see, this question is a classic example where energy is not conserved. In fact, energy is lost, but momentum is conserved. Did you just see that? In fact, I asked you an objective question just some time back. Very good. So let's go to the next question. Let's see how many of you get this. Now, see guys, in this particular question, a bomb at rest explodes into 3 fragments of equal masses. 2 fragments fly at right angles to each other with velocities 9 and 12. And what is the speed of the remaining fragment? Okay, let's think about it. There was a bomb, alright, and let's assume that the bomb's mass is 3m. Why 3m? Because explodes into 3 fragments of equal mass. That is what is given to us. So each fragment will have a mass of m, m and m each. Is that clear? Very good. Now, after the explosion, I'll draw a new diagram. One part flies here, and it is given that 2 of those fragments fly perpendicular to each other. So let me take these 2 fragments. They are flying perpendicular to each other. What are their speeds? 9 meters per second and 12 meters per second. Their masses are m and m respectively. Logically, you can guess the third mass, m, should naturally fly in this direction, isn't it? I do not know what the velocity is. That's what I will figure out. Is this clear? Everyone? Is this clear? Very good. Now, think about it. What was the initial momentum? Well, the bomb was at rest. A bomb at rest. It's clearly given. That means it is 0. So, what should be the final momentum? That should also be 0. So, the final momentum is also 0. But, one second. But this is vector. Understand. The final momentum added vectorially will be 0. So, think about it. Shouldn't these two's resultant cancel out this momentum? This mass and this mass resultant momentum should cancel this mass's momentum. That's what I'm going to do. So P1 and P2's resultant will be equal in magnitude to P3's momentum. If you understand this, there is nothing great about this problem. What is the resultant of these two momentums? Think about it. It will be 12m whole square plus 9m whole square. 9m whole square and the root of that. Why the root? Because I'm taking resultant, right? So a square plus b square ka root, this is using Pythagoras or vector formula, should be equal to the third mass's momentum, which is m into v. I hope this is clear how this has been done. Yes, very good. The third fragment is this one. This is the third fragment. This is fragment number 1. This is fragment number 2. This is fragment number 3. That's it. Solving this, you should get V as 15 meters per second. I hope this is clear. Very good. Very good. If you guys have got it. Excellent. Are you guys now ready for the next level of problem? P1 has mass and velocity. No, this is P final. This is not P1. This is P final. Be careful. Vimraj, why don't you comment after the session in the comment box, not in the live box. I will give you some tips, or you can also contact me on my social media handle, Shreyas_Vedantu. I will definitely help you out. Yes, I'll talk about KVPY 21. Personally message me or put it in the comments. All right, very good. Chalo, let's get going to the next question coming up on your screen, and here it is. Read it. A block of mass is placed on the top of a big block of mass 4m as shown. All surfaces are smooth. The system is released from rest. Okay, I'll leave it. What do you think will happen? Obviously, this block will slide down. Not just that, even this wedge is going to move behind. So this will come down and this is going to push this back. So both of them are going to move. What is the speed of the block when this block reaches the ground and it is going that way? So that is the question. What are the speeds of the blocks? I hope this is clear. Suhas, they are not called logics, they are called as fair assumptions. So you should know, this is very important trick. Suhas, let me tell you, many students whom I have trained always think about some vichitra ideas. So what will happen if this happens? What will happen if this happens? You have to think in the purview of the examination, in the scope of JEE. If you think beyond, too much beyond, then you will always be doubtful. So also understand, yes, you have to learn the basics, only then you can understand it for the real life applications. What if the wood chips off or anything else? So try to make fair assumptions, only then you will be able to solve the questions, or else you will always find it difficult, or you will feel that something is missing. Oh, what should I do? Is it confusing? Etc. Alright? Okay. So 17 has in the previous question, initial momentum was 0 because the bomb was at rest. So final momentum is also 0. That's it. So that's why initial and final both were assumed to be 0. Alright, so let's get going. Let's get going and let's see what happens. So these are the two situations. What was the trick I told? What is the trick I told? I told you always show the first initial and before situations. Only then you can solve the problem. Okay, now let's think about it. Let's think about it. If I take both of them as the system, will I be interested in the velocities, etc., in the y direction, or do you think I'll be interested in the x direction? What do you suggest? Will I be interested in the x direction or in the y direction? Come on, answer in the chat box. Obviously, come on guys, I'm reading all your chats. Yes, x only. So in this system, okay, in this system over here, are there any external forces on this system as a whole from outside? Are there any forces? Are there any forces, guys? Come on, let me know. Are there any forces acting on this system? No, right? Everything is frictionless. This normal force between them is an internal force, so ignore it. It's an internal force. So external force is 0. So from this, can I not say the momentum in the x direction is constant? Okay, momentum in the x direction is constant. Now, if that is true, let's write down equal to. Here I will write down before, and on the RHS I will write down afterwards. What is the momentum of the system before? What should I write down over here? Come on, let me know in the chat box. What is the momentum of the system before? What do you think, guys? What is the momentum of the system before? Yes, very good, VSG. Excellent. 0 Kirito. Yes, very good. Because it was at rest. It's placed on the top of the bigger block. That means it is as shown, it is at rest, it is not moving at all. Now what is the momentum afterwards? Okay, let's assume certain things. Let's assume the velocity to be v1, and let's assume this guy's velocity to be v2. This is v1, that is v2. Okay, so now what do you think is the momentum of this mass? I think it is minus m into v1. Why minus? Because it is left side. Plus, what is the momentum of the wedge? Well, that is 4m into v2. I hope this is clear. I hope this is clear. Everyone, is this clear? Now rearrange this. So what will you get? You will get m v1 is equal to 4m v2. So what will you get next? v1 is 4 times of v2. Oh, so this guy has velocity 4 times this wedge over here. But how much is it? I do not know. I just know it is 4 times more. But what is the value of v2? Do I know that? I don't think so. I do not know that yet. We have to do something. Angel, what did you not understand? Please let me know. Alright. So before, the momentum was 0. Afterwards, the momentum is mv1 but negative, and 4mv2 on the right side. So initial momentum is final momentum, just rearrange, and we got v1 is v2. So as gravity is in the y direction, so it won't matter to us. Anything in the y remains in y, it won't affect the x momentum. So let's ignore that. How do you get all these numbers? What do you mean by that? Is there, that's why. What do you mean by that? Angel, which standard are you in? First of all, you know? Now the problem is I do not know the value of v2. That's not the end of the question. How do I find the velocity, guys? How do I find the velocity? Think about it. How am I going to find the velocity? I need to do. Angel, this is not a 7th standard class. This is a 11th standard class. I think you have come at the wrong place right now, or you have come too early. I think you should come after a few years. Maybe that will be good. All right. Oh yes, energy conservation. We got it. So guys, here is the trick. Assume if this guy has a velocity v, we just got this guy's velocity is 4 times of v. Alright, this guy has velocity v, this has 4 times more velocity than the other one. Alright, so now, so do you guys relate with the Angel out here? Were you guys also like this? What are all these numbers? And suddenly all these things seem easy for you. So that's how it is, guys. Angel, do not worry. These numbers might be scary for you right now, but slowly you will start loving all these numbers and variables and alphabets, and these equations will seem like a cakewalk to all of you, just like it is for all the V enthusiasts out here. So do not worry. Just stay motivated. All right? All right. All right. So guys, what is the energy equation? Whose energy got converted into whose energy? Think about it. I feel the potential energy of M, correct? M had some potential energy and it came down 4m did not come down. 4m is just maintaining its height. It's not, this movement will not cause any change in the potential energy. And it is going in the kinetic energy of m and kinetic energy of 4m also. A lot of people think mgh is half mv square. Wrong, you guys are wrong. No. mgh is not half 4mv square. No. Because even this guy got kinetic energy. And where did it get? This guy has given. It's a very good donor. It's a very charitable man. He has given his own potential energy to this guy as well as this guy. Understand? So, what is the potential energy of m? It is mgh. And what is kinetic energy of m? It is half m 4v square. And what is the kinetic energy of 4m? It is half 4m and v square. Notice I have put a plus because it's a scalar, not a vector. Very good. Very good. I hope this is clear. Yes, we are writing down the formulas. What formulas do you want? Kinetic energy, mgh, everything is written down over here. Now, honey, if you follow all the rules, whatever problems I am giving you, you will revise all the formulas. Don't worry. It's not like I have to sit one day and give you all the formulas and then you'll become the king. Do not worry. When you attend all these sessions, one formula will get registered in your memory. So pay attention. So MMM gets cancelled. So you will get GH, therefore, is equal to, what will this be? 4v square, that is 16. 16 by 2, that's 8. 8v square plus 4 by 2, 2v square. So this will become just 10v square, I suppose. So therefore, I can just say v is nothing but root of GH by 10. Is that clear, guys? Is that clear? Yes, 4 fellow mass gets cancelled again. Is that clear how this problem has to be done? Very good. What a question. Are you guys now ready for the next question coming up on your screen? Let's see how many of you get this. Let's see how many of you get this. Now, this question is your homework question. This question is your homework question. Let's see how many of you get this. Here is the logic. There is a spring, there is a mass. By the way, yesterday's question, not many people have put the solutions or the answers either on my Instagram handle or in the comments. That's why I have not yet uploaded the solution on Telegram. Unless I see a substantial chunk of students sending me the homework in the comment section or on my Instagram, I'm not going to upload the Telegram made the solution of this. Understand? So, you have to compress this mass, leave it. This block will fly. This block will start sliding and it will hit this block. And once it hits the block, it gets stuck to it. And that stuck mass will go like this and go there. So the question is, how much should you compress so that when you release it, the block, when it gets stuck, is just able to complete the circle. So circular motion, work, power, energy, momentum, lot of concepts involved. Yeah, required velocity is root phi gr, but the question is not that. So the question is, what should be the minimum compression in the spring? Read the question. Alright? Alright, will you be able to do this? Suhas, 1, 1, 2, 2 questions also at least you should be able to do as homework. For JEE, you should be solving so many problems. In fact, I gave a lecture on just how to manage time. So manage time and do these homework problems. Very good, very good. Chalo. G can't cancel 10. Yes, it can, Sans Priya, but we often leave G as G only. You just don't bother about that G, leave it as G. Alright, in variables. So let's solve a question on Angry Birds. What about Angry Birds question? Yes, think of it like a slippery cart. Yes, why not? How about an Angry Birds question, guys? Are you guys ready? Alright, let's do this. Here's the question. At the highest point of the angry bird lays an egg such that the egg comes back to the original point. Yes, the egg comes back to the original point. What is the speed of the angry bird just after laying the egg, assuming that the masses are in the ratio of 2:1, and where do you think the bird will fall? Where do you think? Prajwal, I have already made a lecture on that. You can check it. On Monday, I have given a lecture. So don't spam out here. Please see that lecture. I have given all the details in a special lecture of time management. Alright. Come on, let's see how do we do this problem. First concept here. First, let's assume the masses. The masses are in the ratio of 2:1. So this bird's mass, if it is 2m, the anda's mass or the egg's mass is just m, correct? And if I take them as a system, all right, then at the topmost point, think about the initial momentum and also think about the final momentum. If the initial velocity was v and angle is theta, we all know at the topmost point the velocity is horizontal. Y velocity goes away. So what is the horizontal velocity? V is cos component. And how much that will be? V cos theta. But for the momentum, it will be m plus 2m. Why m plus 2m? Because the bird has not yet laid the egg. Just before the laying of the egg, the bird plus the egg's velocity together, the 3m mass, will have a velocity of v cos theta. Is it fine till this point? Very good. Now, understand, in this direction there is no force in the horizontal direction. That's why the momentum before and after is the same, since net force in the x direction is 0. Understand? So I can conserve. No problem, Prajwal, concentrate. I will answer all your doubts, and if you have some doubt apart from the question, please put it up in the comment box. I will always answer it. Do not worry. Okay. Now, if this is clear, what is the momentum after this? Here is the logic. Because it is given that the egg comes back to the initial point of its projection, that means it comes like this. That means the egg's velocity is just reversed and it is now v cos theta, so that it comes back along this path to the original point. So when it reaches the top, it had v cos theta, just reverse it, v cos theta, and it will come back to the same point. Now this angry bird will have some new velocity, I call it v1, correct? So what is the final momentum after that explosion that has happened? Well, the egg's momentum will be minus m and v cos theta, and the angry bird's momentum, well, that will be 2m into v1. Notice the signs, because they are vectors, have to put plus or minus accordingly. Now, Mohammed, don't spam. There is no formula. You have to solve. These are not 8th standard, 9th standard questions where you are given a formula, you have to put in values and you get a magical answer. No, these are not those kind of problems. You have to apply your mind. So that's why we are teaching over here. Alright? And that's why IIT JEE is so tricky examination. Alright, Mohammed? Alright, so now just rearrange this. And what will you get? You will get this as 3m v cos theta. Put this over here. So plus mv cos theta is equal to 2m v1. Now obviously m again bichara cut gaya, and 3 plus 1 4 divided by 2 guys 2. So v1 will be how much? 2 v cos theta, I suppose. Just check it out. Everything is fine. Yeah. So isn't that the speed? I hope this is clear, everyone. Is it clear? Cyber, I will give it to you at the end. First concentrate. Alright. Very good. So Suhas, that was, I don't know whether by magic or by tukka or by luck you got it. So this is the actual way of doing it. Alright. Because if the masses were not in this 1:2 ratio, then your answer will be wrong. Hai na? So be careful. Now, where does the bird fall? Where do you think the bird will fall? That is the second part. Where do you think the bird will fall? Here is the logic. Do you remember in center of mass I told you? In fact, there was a question, a rocket in the air explodes. In spite of that, the center of mass continues its trajectory. Do you remember that? So, even if this angry bird becomes angry, explodes and lays an egg, the center of mass will continue the journey. So the center of mass will continue the journey and it will fall over here. This is where the center of mass will fall. Correct? I hope this is clear. Where is the egg falling? Well, the egg is falling over here. And how much is this distance? That is r, range. Where will the bird fall? The bird will fall somewhere over here. This is where that bird will fall. Now think about it, guys. When the bird falls over here, the mass which lands is 2m and the egg's mass is m. What did I tell you? Did I not tell you a trick in center of mass about the location? Whenever you have masses, the center of mass divides the distance in the inverse ratio of the masses. Didn't I tell you this trick? That's it. Use that and you will get the answer, guys. So if this distance and this distance will be in the inverse ratio, what will you guys get? Think about it. This will be 2, this will be 1. Inverse ratio. So this distance will be r by 2. So that's where the bird will fall. Inverse ratio. Understand that. I hope this is clear and this trick has helped you. It has saved you so much of time, else you will be sitting and scratching your head what to do, etc. So concept of center of mass has been applied. Also the concept, the trick of inverse ratio of the masses has also been applied over here. What a beautiful problem. All right. Is this clear? Let's go ahead. How about this question? Let's see how many of you get this. A man of mass 200 kg is standing on a plank. Mass of the plank is 80 kg. It's on a smooth ice. The man walks from one side to the other of the plank. The distance walked by the man relative to the ice is how much? Given that the length of the plank is 5 meters. Alright, let's see how many of you get this. Starting the question now. Come on, guys. Come on, you can do this. Hardly any time remaining. Let's see. I don't know. 10 seconds to go. No, Krito, it will not depend on the velocity. He goes slowly and stops over there. So it won't depend on the velocity. It will only depend on the initial and the final condition. Even if he walks faster and he goes and finally stops, the plank will always end up there because the center of mass has to stay at rest. Alright, very good, Ankit. Chalo. Now, there are weird ways in which many people talk about this problem, and the worst part is, in those weird, complicated and unreliable ways, you get the answers, but for simple problems. But the moment the problem becomes complicated, then you are stuck. Oh, what to do? Oh my God, sir told me center of mass will not change. So this something. You will get really confused. Do not apply these stupid methods in many books. And whatever has been taught, I will give you one magical formula and that will help you like crazy. Are you guys ready? Because I know it's a simple problem. You can do it little bit by logic also. But for the worst of the worst scenario, in H.C. Verma, there is one question where there is a boat, 2 people walk. And sometimes 3 things are there or 4 things are there. One moves here, the other moves here. Where will the 4th thing move? These kind of questions. So what will you do? You cannot use logic in those cases. It will be very difficult or to visualize as such. So let's get going. Now what is the magical formula? So first of all, let's visualize what is exactly happening. The faded version is the before situation. The darker version is the after situation. Look, in the faded version, this is the plank. The person is here. Now he starts walking. The plank moves behind. Why? Because when the person walks, he will push the plank behind. Alright? So the plank goes here, the person moves here. So understand, I'll assume some variables. Here there are 2 masses, so assume 2 variables. What are those variables? Displacements, but with respect to ground. So S1 is the displacement of person and S2 is the displacement of plank. So this is displacement of the plank and S1 is displacement of person. Now, whenever center of mass is at rest, this magical formula will hold true. What is that magical formula? Many of you might know it, but maybe do not know. You can use it here. It's m1 s1 plus m2 s2 is equal to 0. This is the first formula, magical, which you should use. If there were more people on the plank, then there will be more terms. m1 s1 plus m2 s2 plus m3 s3 plus m4 s4 will be 0. Are you getting it? So this is the first thing that you should use. So let's use that and see what you get. You will get mass of the person m1 is 200 into s1 plus m2 mass of the plank 80 s2 is equal to 0. Therefore, think about it. I can just cancel few zeros and just divide few things, and I think I will get divided by 4. So 5 s1 plus 2 s2 is equal to 0. This is equation 1. Is this clear, guys? Everyone? Is this clear? Yes. Now, if this is clear, let's do one thing. I have two variables but only one equation. I need one more equation. Where do I get it from? Read it carefully. The person walks. I have not used all the information, so I need something else. The person walks from one end to the other end. Okay. Now just visualize, guys. This is the plank. Okay. This is the plank. The person is here. If the person moves here, relative to the plank, how much has he moved? He has moved the length of the plank, right? Yeah, the plank might move behind. That's okay. But for the plank, how much has the person moved? He has moved exactly those 5 meters, which is the length of the plank. If this is clear, that's it. That's the next trick. Displacement of person with respect to the plank will be the length of the plank. So this is the second magical trick which you need to use. Relative motion. So always for these kind of problems, number one, use this formula m1 s1 plus m2 s2 plus m3 s3 is equal to 0. Second or third formula will be relative motion. Displacement of each person relative to the plank, and that's it. That will give you the answer. So guys, what is displacement of the person relative to the plank? I feel if you sit on the plank, you will see the person walking this way, and I think it is -5. So s1, okay, one sec, s12 is s1 minus s2 will be -5, because that's the definition of relative motion. Remember, v12 is v1 minus v2, a12 is a1 minus a2. So S12 is S1 minus S2. Just substitute now. There is nothing great about it. Now from this equation only, if you want, because this is 0, you will get S1 is equal to -2 S2, alright, divided by 5. So I will call this equation 1. Substitute it here and see what you will get. You will get S1 is -2 S2 divided by 5 minus S2 is equal to -5. Alright. So this will become -5 minus 2 -7. So I believe it will become -7 by 5. S2 is equal to -5. Minus cancels. So therefore I will get S2 as how much? I'll get it as 25 by 7 meters. Just check it out. Is it correct? Is it correct? Yes. Now, if this is the case, what will be S1? S1 will be -2 by 5 times of this number, which is 25 by 7. So what will it be? What will it be? Yes, 5 cancels, so -2 into 5 -10, so -10 by 7 meters. Now I got the answer as negative. What does it mean? You will automatically get the answer as negative. You don't have to apply any brains. This negative means the person's displacement is towards the left side, and S2 being positive means the plank has moved towards the right side. So this is really wonderful. You don't have to do anything. Automatically the answer comes in signs also. Correct. Isn't this beautiful? Now there are 100 masses also you can solve it. It's just that the number of equations will increase, that's all. But at least you can make the equations, right? I hope you got it. So that's how you get it. 25 by 7 and -10 by 7. I'm not sure if anything. Oh, I think the answer given over here was none of them. Guys, I think this is wrong. This is wrong. ये कुछ गड़बड़ है इधर. Okay, this is wrong. This is wrong. Okay. So the options only were wrong. I need to correct it. Don't worry, I'll update it in the PDF as well. I hope this was clear. What a session it has been. And for all the dropper students, I have already told that you have a special crash course running. So in case you want to join the crash course and avail all the benefits, please do, because you have a separate crash course if you do not want the pro subscription, only for the droppers and the 12th standard students. Alright, the entire course will be covered. You will not miss any lectures, recordings, tests, assignments, discussions, doubts, live classes, you name it. All the things are there for 10,000 rupees, but 20% off, of course. So it will become 8,000 rupees for 12th and the dropper students. Again, you have to use the same coupon code. This is different coupon code. It is SHCC. That's a different coupon code for the crash course. For the pro courses, it is SHHPRO. So use this. The link is in the description box below. And do not forget to join the Telegram group. And those of you who are asking what is my Instagram handle, it is Shreyas_Vedantu. Right? So you can find me on Instagram. And do not forget to post the answers of today's as well as the previous sessions, or else I will not post the solution on Instagram. Was it wonderful, guys? Did you guys have fun? More importantly, did you guys have fun? Did you guys enjoy? Did you guys learn? Did you find the session beneficial? Then what you should do, you should go and like, right? So please go ahead and like the session in case you haven't. Oh, is it Suhas? Please send it to me. No problem. Send it to me. No problem. On Instagram. Oh yes, thank you Uncharted for reminding me. So tomorrow, the chapters for Menti quiz, 12th standard guys, it will be electrostatics and gravitation. Only forces, field lines, gravitation, acceleration at depth d and height h, all these, and conductors, insulators and their properties. All these questions are going to come tomorrow. Tomorrow, it will be, I think, at 11 o'clock if I'm not wrong. So tomorrow, Menti class at 11 o'clock for all the 12th standard and the dropper students, and even 11th standard students are welcome, but provided you know about electrostatics and gravitation. Alright, is that clear, guys? Thank you Janvi so much, thank you Akhil, thank you Aarti. Alright Suhas, amazing, very good. Very good. Thank you Ayush. Bye bye, take care guys. See you, have fun. Good day and good night.